D1, D2, D3, D5, and then there are 2 more here. Then we have communication port. Before going to communication port, I will explain about the inputs. In CCC controllers, these channels are already assigned to a particular application or measurement. So channel 1 is always connected to your flow transmitter. You cannot change it to another channel. So flow transmitter is connected to channel 1. Discharge pressure is connected to channel 2, and suction pressure is connected to channel 3. Channel 4 is spare, you can connect anything like that. Channel 5 is discharge temperature, channel 6 is suction temperature, channel 7 anything. Here you have connected to RLC, remote local arm. And then channel 8 you can connect anything. So what you have done, the same output is looped via channel 8. So if you open the wire at the positioner, channel 8 will fail, and then you can know the signal fail. The loop is open. Same base, the first relay is assigned to fault contact. The other relays you can assign through the laptop. You can assign what function. It can represent a recycle trip event, or safety on, or it can be a transmitter failure like that. Same discrete input also is assigned. D1 typically used for other controller, redundant tracking. D2 is for shutdown. And then D3 is you can now use anything. Then D4 is for the recycle trip. When the booster compressor trips, you get a contact, right, in the first stage. That is connected to D4. So when the D4 contact changes, valve jumps over. So all these inputs are pre-assigned. Whereas in our newer products, Series 5, Series 6, with multi inputs, there is no such assignment. You can connect any signal to anywhere, and then the control application can use it.
The 4 channel fails. Keep the channel on the 4 signal.
No. If the input fails, in the front panel it will say fail, signal fail. Controller will go to fallback mode, but you cannot substitute another value. No, you cannot. You cannot. You cannot. Instead of channel 1, I want to use channel 4 as spare run of the. You can do that one in other like Series 5 or the full digit system, but not in Series 3. Controller தான் change பண்ணு. ஒரு input channel fail ஆனாலும் controller change பண்ணு. But
அது 420 விட்டாங்கன்னா நம்ம 1 to 5 வோல்ட் அவுட் ஆகுமா?
No, I don't think so. என்ன உள்ள அப்படின்னா it's a 420 mA. Inside it goes to a 100 ohm resistor. If it's a voltage, you have an external 250 ohm, no? So still it is going to the resistors. So two resistors parallel, so it will not work. You have to change the switch selection to voltage type, and that time it will disconnect that 100 ohm resistor. 100 ohm resistor failனால the channel work பண்ணலனா yes
ஒரே ஒரு சேனல்ல மட்டும் நான் வந்து 1 to 5 வோல்ட் செலக்ஷன் பண்ண முடியும்.
yes பண்ண முடியும். எப்போ நீங்க சொல்றது வர்க் ஆகும்னா if the failure is that resistor. See, the signal goes inside there's a 100 ohm resistor and then comes out. So 420 mA is converted into 0.4 to 2 volts inside. The moment you change inside the dip switch from current to voltage, then the 100 ohm resistor is removed. So whatever you give 1 to 5 volt, it's directly processed. You can use it. But what is the chance of probability of only the resistor failure? So another or input channel fail ஆச்சுன்னா I believe 99% you have to replace the controller. But good thing is, I never seen a failure. As I said, this product came in year 2000, and I first controller I installed is around like 2001. I have not seen like a channel failure, one single failure. Okay, these are all the field inputs. Now let us come to the other terminals. This is port 1, port 2, and then we have port 3, port 4, and then port 5. You can see port 5 not used, so we don't care about this one. But port 1, 2, 3, 4, it's used. Port 1 and port 2 part internal communication between CCC controllers. Port 3 and port 4 are Modbus communications. You can connect it to a DCS. You can connect to both ports also if you want to have a redundancy. Normally one is connected to DCS and another is connected to like a laptop. We also have another version where suppose your DCS doesn't support the serial connection. If it wants Ethernet connections, you can have this type of
Ethernet.
So this is easy to convert. You only have to change the end plate. That's not a Modbus, it's usually a proprietary language. Only CCC controller can understand. If you connect port 1 to DCS, they will not communicate because it's a proprietary own language. What it sends is how much the controller is opened, what is the mode, auto or manual, whether it's a run stop. Such status they exchange for a coordinated control. In your case, performance controller sends speed set point to the speed controller. That is through this port communication. It's you will not see any wiring on the backside. So it changes the signals. So the performance controller output is sent as a set point to the speed controller.
And the wiring master plus slave wiring.
That is port 2.
Port 2.
Yes. Here if you see port 1 is only 2 wire. There is no master slave. They are all in one. But whereas port 2 we have a master and then slaves.
Port 2
Yeah, port 1 is something like a controller output, controller modes, its status, run stop status. Port 2 is like pressure override control, load sharing control. You know load sharing control. If you have multiple parallel compressors, so they all operate in to control one suction header pressure or common discharge pressure. So அதுக்கு வந்து we use port 2 communication. இங்க வந்து we only use for POP, pressure override control, because POP control loop is in the performance controller, but that output is going to the first stage anti-serial block. So that is via this port 2 communication.
The speed set point, SIC set point, port 2.
No, the speed set point is sent, there is an output, no? That is sent over port 1. அதனால தான் இப்போ நீங்கள் ஏர்லியராக சீரிஸ் 3+ கண்ட்ரோலர் இருந்தப்ப யூ ஒன்லி ஹேட் போர்ட் 1 கம்யூனிகேஷன், போர்ட் 2 இல்லை. இந்த தடவை தான் போர்ட் 2 கனெக்ட் பண்ணியிருக்கு.
கமாண்ட் தான் 2 இருக்கும்.
எஸ்,
அது போர்ட் 1 போர்ட் 2 தனி ப்ரீ டிஃபைன்டா சார்?
எஸ் எஸ். See, that's separate terminals. So then we have a different purposes. Each one is used for a different purpose. If you ever see in the controller there's a COM failure, all you have to do is go and see backside is plugged in properly. Suppose if you are working something, you remove the plug. Afterwards, you didn't connect it, press it in the thing. That's one possible problem. If you see communication error in the controller base plate, go to the backside and press this. Or look for loose connections.
Increase the anti-sense, other flow pressure, other sense, the performance control, the port communication.
No. all controls are within the list. So they don't rely on communication can failure. Yeah. So the communication is only for optimization. The main control functions all will be within this. That is why you cannot use this signal, the connected a flow signal here to another control. The control is critical. The pressure override control is something optimized. You improve the control. Right? Okay, these are about the unlock inputs, unlock outputs, all these things I explained. Any questions here? So, possible troubleshooting. Let us say one input failed, flow transmitter failed. There are two things. A value reading 0 or saturation is not a failure. Let's say if you see all the small transmitter, if there is a over range or under range, the output goes to one value. Like if it's a rose mode, it goes to 3.9 milliamps. If there is a sensor failure or electronic failure inside the transmitter, the output will go to 3.75 milliamps. If you see the data sheet, it's explained. One is saturation value and another is failure value. Saturation can be a temporary. So once your maybe your line got choked, impulse line got choked, right? So you go and clear the impulse line, it will come out of saturation. So that is not considered as a failure. A failure is one where the milliamp drops below 3.8 milliamps or open wire. So you have to make this one difference. Suppose tomorrow you go there and the value is reading 0, operator tells the transmitter has failed. Look at the value. If it's 0 and there's no failure, it's most likely it's a saturation. There's a condensate inside or something like that, or blockage. But if it says fail, then it is not a process problem. It is your connection problem or your device problem. Saturation, what can be the reasons for saturation? Actually, there may be a higher pressure in the pipeline. They may start the compressor with a higher set load pressure, or one of the impulse line get choked. These are the two possible reasons for saturation. For failure, it can be electronic failure, it can be a fuse power supply failure, 24 volt DC, or open wire, or reverse polarity, or in the CCC controller inside circuit is failed. So there can be many different reasons. So you have to eliminate one by one. I do the troubleshooting most of the time being what is called a process of elimination. So you list out what are the possible reasons, one by one. Okay, this is not the reason. I see the power. I measure 24 volt DC. That means power is okay, fuse is okay. Then I check milliamps. Yeah, I'm getting 8 milliamps. This is normal. But what would be the reason? It may be a reverse polarity. Right? So one by one you rule out, and then you can find out what the problem is. Any other questions in signal problems?
Serial port.
Serial port? Ethernet. So suppose tomorrow you are upgrading DCS. In the DCS, they say no, we support only the Ethernet gateways, not serial port gateways. You can order only the back plate, remove that, and then you can insert it. And then you have two ports, port 3 and port 4. You can connect multiple devices. Now in the serial port, the problem is you can connect only one device. Because Ethernet, you can connect multiple devices. I can connect my laptop. At the same time, this signal also can go to DCS. Sometimes the serial, because serial is outdated, old technology. If you buy a gateway with the Ethernet, serial gateway, that may be a costlier than an Ethernet ports. So you look at the cost difference. For that you can convert this one into Ethernet. So this we call it as compressor controller, because this is used typically for compressor controls. Now we have steam turbine controls, right? There is some difference there. I will show you. See, this is a compressor controls, and then this is your steam turbine speed controller. The reason is there are more inputs in speed controller, like the speed inputs. Sometimes you have a steam valve LVDT signals. You don't have a space to connect it here. So we use external, what is called field termination panels, FIM or FOM. You have two. FIM means field input module, FOM means field output module. So you have two strips like this. This is a field input module. So the termination, you are moving away from the controller. And this is a multi-core cable. You connect a multi-core cable and then you connect it to the controller. And then you have another board only for outputs, field output modules. So you have these things only for speed controller, which is, we call it as a turbine controller. So you have two cables, one for inputs and another for outputs. The rest all same. You have a power for the controller. All the CD ports also included in the FOM. Yesterday we had one problem. One discrete input didn't work. Still we do not know. We just replaced the board. But actually the board doesn't have any active components. There are no ICs. They only have a terminal strip and then some jumpers. That's it. It could be I suspect only a bad connections here, multi-core.
Yes.
So when you are working on the speed controller, you have this printout. So this is there in the manual. So you can find out what are the terminals for inputs or machines. This will be handy. Even yesterday, I was opening this manual to see where this D1 is connected. So D1 is connected here. So pin number 3 and 4. Without this drawing, it's very difficult to work on that.
Okay.
Now we come to the front side. So the back side we have seen. One thing I forgot to tell. You can remove this plugs, make a connection outside. You can have good connections, and then you insert it. That's easy. And then when you are replacing your controller, no need to disconnect any wire. Unplug these cables. You can mark it 1, 2, 3, 4, 5 so that you don't make a mistake. You cannot put this one. You can put it, but if you have labels, then you can correctly insert.
Yes.
Coming to this first one, this is anti-surge controller. All are same, only this sticker is different. So this sticker can be replaced. So you have a, let's say, anti-surge controller, but a performance controller failed. You can use it there. The only thing is this there's a sticker saying that you can remove it and then replace it. The anti-surge controller or performance controller, the top one it says the variable you are controlling. what you are trying to control. I am going to control maintain the deviation positive or 0. In the performance controller, this is like your suction pressure. So this will be always lit. The second line here, it's a set point. In anti-switch controller, set point is the such control line. Tomorrow I will explain. That's fixed inside. That's why nothing is shown here. Total P decides, but basically it is a 0 deviation. If this value is above this value, valve will close. If this value is below 0, it will open the valve like that. Same way here. If the suction pressure is more than the set point, in ammonia compressor, speed will be increased. Why? Because you have more suction pressure available. If it is less than the set point, it will decrease the speed. In CCC controller, the outputs are always shown as percentage open. No confusion. It's always percentage open. Even if you have a signal to close or signal to open valve, there are two types of valves. Some valves you have to give 20 milliamps to close it, some valve you have to give 20 milliamps to open it. So inside the controller we can reverse it, but the display will always show percentage open. And then there are some additional buttons because this controller has got multiple PA loops inside. Although I say this is a single loop controller, it doesn't mean single PID. It has got multiple PID inside. One is for deviation control, then you can have for suction pressure control, discharge pressure control. Then you have some display. It has got several, it's grouped into several variables. So you can change that group by pressing this menu button. Then each group, you press scroll to go down. For example, you press this one to display a transmitted value, signal value. You can use scroll to change it to another input. If there is a fault in the controller, the red light will indicate. Before that, I will explain one common disease. If everything is shown green, all the lights are green, everything is fine. So no need to do anything. So green signal you can go, like in the highway. If it's yellow, your attention is required. You have to watch. Something it requires. Like if the controller is in manual, it will be yellow color. If it is auto, green color. Auto means you don't do anything. Just look at it and then you go away. If it is yellow, oh, it's in manual, that means the output I have to change. But something is red, it requires, oh, there is something wrong. So you call, I tell operator to call instrument people to look at it. So the fault is in red color, but alarm is in yellow color. Then if the machine sets, you will have a red alarm, that means set. So you have to go and look at it. When it is in auto, these buttons, they don't work. But when it is in manual, pressing this one increases the output, pressing this button decreases the output. Simple. These buttons are not used in anti-switch application, but in performance it is used to change the set point, local set point or remote set point. What is local set point? If you are changing it locally on the controller, it is called a local set point. But if you are changing from somewhere else, like a DCS or from another controller, it's called a remote set point. For example, speed controller, if it is remote, that means the set point is coming from another controller. Performance controller, remote means the set point comes from DCS. So operators sometimes they may be confused, so you have to fix them. Auto means it will compare the set point and changes the output. Manual means it doesn't change the output on its own. you change it. If no, that manual means it need not be tracking. That can happen even when it's not auto. Yeah, that is a different display. This output is sent to speed controller as a set point. But if the speed controller is not listening to it, it's not using it, then it should not keep on changing the output, no? Because speed controller is not using that signal, it's in local. At that time, this controller output will track the actual set point. Why it has to track? Tomorrow you go and change it to remote, there should not be a count. Because, say, let us say I am giving you some instruction, and then for some time you say, no, I am not listening. So I have to keep following you. That's called a tracking. No, manually. Yes. You manual put it as speed controller local, still you will see tracking. Auto output also tracking. Yes. When it is in tracking, you cannot change the output. Because it's just that is, the other controller is dictating.
Search auto இருக்கும். Search auto இருக்கும்.
Yes.
Search reset இருக்கும்.
Search reset. Okay, good question. Actually, it's an application. Tomorrow, no issue. If the machine went into search, if you know why it searched, you can reset. Suppose you are starting the plant, the flow is going up and down. At the time it is searching means operator can reset. Or he wants to reduce the speed by 10 RPM. By mistake, let us say he reduces it by 100 RPM. Machine goes to search. Then he can reset. Other case, everything is running, next week you are coming, suddenly you see the search, because the plant was running full load, everything was set, but you will see the search count, then you have to investigate. Maybe your recycle valve got stuck, or your flow transmitter has condensate, giving a wrong signal. So you investigate, you fix the problem, then you come and reset. Yes. I will explain that with the theory tomorrow. Tomorrow or whenever.
சார் இந்த பர்ஃபார்மன்ஸ் கண்ட்ரோலரோட வேலை, அதாவது இன்புட் எது, டிவி எது, செட் பாயிண்ட் எது, அவுட்புட் எது, அதே மாதிரி ஸ்பீட் கண்ட்ரோல். இது கொஞ்சம் சிம்பிளாக நாளைக்கு நீங்கள் எக்ஸ்பிளைன் பண்ணால் இன்னைக்கு கொஞ்சம் சிம்பிளாக சொன்னீங்கன்னா, ஏன்னா இப்போ நீங்கள் சொல்கிறீங்கல்ல அது என்னென்ன நடைபெறும்.
Another time, most of the points are covered already. I will explain.
சொல்லிட்டு இதெல்லாம் சொன்னீங்கன்னா
So, what is the deviation? The anti-search controller